Hello everyone, welcome to today's module on disk forensics. Let's start with the introduction. Dear friends, computer forensic investigation include the systematic collection and examination of digital data. Since the magnetic media are widely used for permanent storage in personal computers, as already mentioned in our previous module on hard disk, that it is called as the black box of the computer, having bundle of information stored permanently on it. Rather, it is the most crucial evidence a digital forensic expert search for. So, there is growing demand for experts in the area of data recovery and electronic evidence from magnetic media. Disk forensic is the specialized branch of digital forensic which deals with the science of extracting forensic information from digital storage media like hard disks, USB devices, CD, DVD, flash drives, floppy disks, etc. So, in today's lecture, we shall delve deep in reference to seizure of such storage media and extracting data and information from seized media and utilizing them in solving computer crimes. We would cover following modules: how information is stored in such digital medias, seizure of digital storage media, importance of system boot, write blocking and bitstream imaging, physical and logical analysis. Before we start, let us quickly revise how the data is stored on hard disk. Data is stored on the hard disk in the form of zeros and ones as tiny magnetized regions on platter, where each region represents a bit. Bits of data are arranged in concentric circular path called tracks. Each track is broken up into smaller areas called sectors. Information is usually stored in 512 byte sector in concentric circle track of decreasing radius. A cluster in context to hard disk refers to a group of sectors within a disk, frequently ranges from 8 to 16 sectors. The disk operating system and Windows file system use fixed size clusters. It is smallest logical array of disk space that can be allocated to hold a file. Even if a file is small in comparison to the size of cluster, an entire cluster is reserved for the file, which creates lot of unused waste space on the disk called as the slack space. This slack space is very important forensically, as it provides a great opportunity for forensic investigator to retrieve traces of deleted files, metadata, fragments which can be very crucial to provide a link for computer crime under investigation. The simple sector addressing scheme is explained by CHS addressing or cylinder, head and sector addressing. For more detail, you can revise our module on CHS and LBA addressing. Dear friends, part of the hard drive store a map or record of sectors that have already been used up and others that are still free. In Windows, this map is called as File Allocation Table or FAT. In modern version, the NTFS or the New Technology File System is used. When the computer wants to store any new information, it takes a look at the map to find free sectors and then instruct the read-write head to move across the platter to exactly store the data at right location. It is important to mention here about the partitions. You know, a physical disk may be further divided into several separate logical disks called as partitions. Each of them can accommodate a distinct file system and each of which has its own file map situated at the start of that partition. So, a disk is thoroughly searched both physically and logically, which we would discuss in next section of our lecture. Let us now look how digital storage media is seized as evidence and what different steps are involved. In first step, there is need to be thorough preparation. In this step, make sure all the evidence collection tools are updated and licensed for utilization. In next step, photography and notes. The investigating team must keep a record of actual crime scene. For that, some guidelines are there. Photograph the crime scene, whether it is a room in the home or it is a business house. Usually SLR camera is the preferred choice for taking photographs, although digital cameras seems to be an emerging standard for taking photographs. Make proper notes of all the items, eyewitnesses, physical state of the scene should be taken. Photograph the actual evidence. Take the photograph of the monitor. What is on the screen? Take a photograph of the PC. Remove the case cover carefully and photograph the internal cabinet. Document and label all the hardware, the internal drives, peripheral components, configurations, serial number, etc. Make sure you document the configuration of the cables and connections as well. Photograph the evidence again after labels have been applied. If required, go for videography of the crime scene. In step 3, transport. Securely pack all the evidence and transport in anti-static envelopes. As already mentioned that the integrity of data stored in such magnetic storage media should not be challenged at any point. So, there are some guiding principles that an expert should always take care while handling such digital evidences. Remember, don't perform any such action which would change the validity of digital media. Only an authorized person should be allowed to access the seized digital media. There should be proper record of the documentation regarding the collection, seizure, preservation and transport of the digital media. The chain of custody should always be maintained to avoid any alteration in seized evidence. Let us now understand what is the importance of system boot in ensuring the validity of the evidence. You know, once the seizure is over, it is an ordeal to search for relevant evidence in the ocean of data available on the hard disk. Since there are no strict standards regarding the admissibility of digital evidence, and this may even create problems for the parties involved in the court case related with the cybercrime. We know that even opening a file will change its attributes related with the last access, last modification, etc. Hence, only certified cyber forensic investigator should be authorized to analyze the digital evidence related with the cyber crimes. System boot in such situation must be undertaken in such a manner which avoid any modification to the content of the disk or files being examined or imaged. It also evades the possibility of any modification to metadata or descriptive information that describe either the system or the disk and the files. For this, forensic investigators need to bypass the default booting process and need to boot the system using their own specialized boot disk or compact disk that is configured to boot the system in controlled manner. This is done by changing the boot source to a floppy disk or compact disk drive during the system startup. Let's now talk about our next topic, write blocking and bitstream imaging. Now, once the system is booted, the assurance of continued protection of the original disk and files from being modified by the system relies on the write blocker technology. A write blocker can be implemented in either hardware or software formats. Write blocker is a specialized type of the computer hard disk controller tool for the purpose of gaining read-only access to the computer hard drives, therefore guarantee the integrity of data. Bitstream imaging. Dear friends, finding relevant information from a disk can be sometimes easy by locating files on the hard disk by name and then verifying their contents, or sometimes needs special procedure by extracting information portion by portion from system or from the slack space lying on the disk, and then they can be carefully assembled together. It depends upon the careful non-invasive imaging of the original data disk to a trusted bit by bit copy which can then be searched without the possibility of damaging the original version. Disk imaging can be defined as the process of copying a hard drive either as a backup copy or as an archive. The process includes the copying the entire data that is stored on the source drive, including the table allocation information. Disk imaging takes place when the computer has been seized according to the set of procedures like serving warrant or then kept properly in the custody. Once the imaging is complete, further analysis can be undertaken on the duplicates with an assurance that the integrity of the original evidence is not compromised. Usually the entire disk is imaged in order to allow the subsequent analysis at both physical and logical level. Let us more clearly understand what do we mean by bitstream image of the original media. As mentioned, bitstream image is a sector by sector or bit by bit copy of the hard drive. A bitstream image is actually a set of files that can be used to create an exact copy of the hard drive, preserving all hidden data in addition to the files and directly structure. And let us see how it is done. The computer forensic examiner creates the bitstream image by attaching the original computer media to a write protection device that ensures no writes can take place to the original media while the bitstream image is created. The biggest benefit of creating bitstream of the original media or the disk image is that we can legally carry out the physical and logical analysis while the original disk remains safe and can be produced in the court as an evidence. There are various methods of imaging. In fact, it is generally not possible to create the entire duplicate, but with available tools, the investigator tries to create copies that are as close to the original disk as possible. Sometimes the entire data on the hard disk may not be needed, then we go for selective copying in such cases. There are various ways to have the disk imaging. Type of disk imaging, sector by sector. The image disk comprises the same sectors in the same sequence as in case of the original disk. Physical imaging, which is commonly used term to signify a sector by sector imaging, which is most acceptable in court of law. Disk mirroring. Disk mirroring often refers to RAID 1, that is redundant array of independent disk 1, is a form of disk backup in which anything that is written to a disk is simultaneously written to a second disk. In this technique, the data is duplicated by being written to two or more identical hard drives, all of which are connected to one disk controller card. If one hard drive fails, the data can be retrieved from the other mirrored hard drives. In this technique, mapping of the tracks, sectors and cylinders of the original hard disk to the duplicate can be attempted. Bit by bit imaging. This is the ambiguous term. It can be used as a synonym for disk mirroring or it can be used for sector by sector duplicate. Then there is partition imaging. This is sector by sector imaging of a single partition. Please remember, even the copies should be kept with equal care in a secured zone where intruders cannot get in physically or electronically, and the original disk is kept safely, untouched to preserve its sanity. Dear all, please remember that the investigators are supposed to work on forensically sterile media so that the original storage units remain intact. This means that any previous data must be completely removed from the media with some software that is capable of removing all the data from the drive. A normal formatting of the hard drive will not actually remove all the files. When forensic specialists use sterile media, they are ensuring that the media itself will not contaminate the acquired evidences. Now let us know about the physical and logical analysis of the disk image. A logical analysis can only examine the contents of allocated space. Allocated space means the area on the hard drive where files are actually residing. Cannot attempt to find files intentionally deleted by the user as in case of physical analysis. It provides a high level or semantic view of the file contents. Let us see what is physical analysis. Disk image analysis at the physical level allows an analysis of the disk image, sector by sector, and by definition provide analysis of each disk partition in the image. Analysis at the physical level is important in situation in which there is likelihood of forensically valuable information appearing on the disk in ambient data areas. In this case, a detailed physical analysis of the disk image needs to be carried out either at the site of the investigation or later in the forensic laboratory. Information that is residual or hidden in ambient data areas will otherwise be overlooked. Sector-wise analysis is carried out specifically to gather ambient data that may contain useful clues and evidence for analysis. Ambient data are those data which are fragments of the already deleted files, hidden files, metadata and backups which are not evident on the servers or the drives and are not accessible logically or via applications. Though when delete files, they are not actually deleted, but they are simply marked for deletion as unallocated or free space in the file map, and they get eventually replaced by the data of new files. Not all data get overwritten. The slack portion of the old file can still be retrieved using hardware and software mechanisms. Many a times the ambient files may be tampered or deleted in order to prevent the discovery of tampering. There are various hardware and software mechanisms to retrieve such deleted files. The investigators do their best to capture as much as relevant data as possible to facilitate smooth work that will be based on reliable information and will give satisfactory results. One of the most important analysis is file slack space, which refers to the space left over in the last cluster allocated to a file. Residual information appearing in a file slack space is not accessible using standard file processing utilities. Nonetheless, data residing in file slack space is potentially of forensic value. System swap files, known as page files in the Microsoft, too will contain residual data, which is of great value. Swap files will include residual information, such as from previously opened files and print spooling, and is more sophisticated tools allow an investigator to check such areas. Latent data and fragile data are of related terms of interest. Latent data reflects the fact that the disk information, even after being overwritten one or more times, can be recovered using specialized techniques including magnetic force microscopy. Some important tools used for disk forensic are CyberCheck Suite by CDEC, FTK and FTK Imager, Autopsy, SleuthKit and Case are few common tools used for the analysis of disk. Let us summarize. After a security system has been breached or crime has been committed using computer or electronic devices, the need of computer forensic expert is realized. Information stored on devices such as hard disk drives, CDs and USB flash drives, etc. are commonly examined to restore information deliberately or accidentally damaged. This job becomes more challenging with mass storage media, when magnetic tape and optical technologies are seized as evidence. Forensic cloning is one option available to preserve such kinds of the media such as hard drives and removable media such as flash drives. It serves as a gold standard of data preservation In that, it preserves all the data on a piece of media. Not just the active data, the use of the hardware write blocker ensures the integrity of original evidence. The evidence recovery is very helpful in the litigation of case. So dear friends, I conclude here. Hope by now you are even more curious to know more about the digital forensic. So stay connected for our upcoming modules. See you, take care, goodbye.